In this video, we will explore C++ function parameters and the different ways to pass data to functions. Understanding these methods is crucial for writing efficient and safe C++ code. Let's start with pass by value. The key characteristics of pass by value are that it creates a copy of the argument. The function works with this copy, not the original variable. This means any changes made to the parameter inside the function do not affect the original value outside the function. Pass by value is safe because it preserves the original data, but it can be potentially inefficient, especially when dealing with large objects due to the overhead of copying. Here is an example. A function called increment by value takes an integer number as a parameter. Inside the function, number is increment by 1, and the value is printed. In the main function, an integer x is initialized to 10. The increment by value function is called with x as the argument. After the function call, the value of x is printed again. You'll notice that the value of x remains 10, even though it was increment inside the function. This is because the function only modified its local copy of x. Next, we have pass by reference. In pass by reference, instead of creating a copy, an alias to the original variable is created. The function works directly with the original variable. Any changes to the parameter inside the function will affect the original value outside the function. Pass by reference is more efficient, especially for large objects, because no copying is involved. The ampersand symbol is used in the parameter declaration to indicate that it is a reference parameter. Here's an example to illustrate. A function increment by reference takes an integer reference number as a parameter. Inside the function, number is increment by 1, and the value is printed. In the main function, an integer x is initialized to 10. The increment by reference function is called with x as the argument. After the function call, the value of x is printed again. You'll observe that the value of x is now 11, because the function directly modified the original variable. Now let's discuss pass by pointer. In pass by pointer, the memory address of a variable is passed to the function. To access or modify the value at that address, dereferencing is required. Changes made to the dereference pointer will affect the original value. The pointer itself can be modified to point to a different memory location. It's also possible to pass a null pointer, indicating that the pointer does not point to any valid memory location. Here is an example. A function called increment by pointer takes an integer pointer number ptr as a parameter. Inside the function, the value pointed to by number ptr is increment by 1 using the dereference operator, and the value is printed. In the main function, an integer x is initialized to 10. The increment by pointer function is called with the address of x, using the ampersand operator. After the function call, the value of x is printed again. The output shows that the value of x has been modified to 11, because the function modified the value at the memory address pointed to by number ptr. Let's compare the three parameter passing methods. In terms of syntax, pass by value is void function integer x, pass by reference is void function integer ampersand x, and pass by pointer is void function integer asterisk x. When calling the function, pass by value is function number, pass by reference is function number, and pass by pointer is function ampersand number. In terms of memory, pass by value creates a copy, pass by reference is an alias to the original, and pass by pointer passes the address to the original. Pass by value does not modify the original variable, while pass by reference and pass by pointer do modify the original. Null is possible in pass by pointer but not possible in pass by value or pass by reference. Pass by value is slower for large objects while pass by reference and pass by pointer are efficient. Const references are a best practice and combine the efficiency of references with safety. They're used for read-only access, preventing accidental modification of the referenced object. This is especially useful for large objects where copying would be inefficient, and the compiler enforces const correctness, preventing any attempts to modify the object through the const reference. An example is a function called printVector takes a const reference to a vector of integers as a parameter. The const keyword ensures that the function cannot modify the original vector. Inside the function, a range-based for loop iterates through the elements of the vector and prints each number. Attempting to use the pushback function on the vector inside the printVector function would result in a compiler error, because the vector is passed as a const reference, indicating that it should not be modified. Default parameters provide fallback values for function parameters, making functions more flexible. Default values are specified in the function declaration, and any default parameters must be the rightmost parameters in the list. They can be combined with any of the parameter passing methods we've discussed. In this example, the function setDisplay has 3 parameters: width with a default value of 1920, height with a default value of 1080, and fullscreen with a default value of true. The function prints the dimensions of the display and indicates whether it is in fullscreen mode. In the main function, the setDisplay function is called with different sets of arguments, demonstrating how the default values are used when arguments are omitted. Calling the function with no arguments uses all the default values. Calling the function with just the width and height uses those custom values, and the default value for fullscreen. Finally, calling the function with all 3 arguments uses all custom values. When passing arrays to functions in C++, it's important to know that arrays decay to pointers. This means the size information of the array is lost, and you need to pass the size separately. Changes made to the array elements inside the function will affect the original array. A more modern alternative is to use standard array or standard vector, which provide more safety and functionality. Here are 2 examples. The first example shows how to pass a C-style array to a function. The process array function takes an integer array ARR and its size as parameters. Inside the function, it iterates through the array, multiplying each element by 2, modifying the original array. The second example demonstrates the modern approach using standard array. The process modern array function takes a standard array of integers as a parameter and modifies the original array in a similar way. When designing functions, you often have a choice between using return values or output parameters to return data to the caller. Modern C++ prefers return values over output parameters whenever possible. Standard tuple can be used for returning multiple values, and standard pair can be used for returning 2 values. Structured binding provides a cleaner syntax for unpacking the return values. Let's look at 2 approaches. One approach, the modern approach, is returning multiple values with standard tuple, and another approach is the traditional approach where we use reference parameters for output. In modern C++, we prefer return values over output parameters, and the reason is because modern C++ offers standard tuple for returning multiple values, standard pair for returning 2 values, and structured binding for cleaner syntax. Here are some best practices for C++ function parameters. Pass built-in types and small objects by value. Use const references for large read-only objects. Use non-const references for objects you need to modify. Use pointers for optional parameters that can be null. Prefer return values over output parameters with structured bindings, and use smart pointers for ownership transfer. Choose the parameter passing method based on size, mutability needs, and ownership semantics. If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.